Welcome back, everybody. For this section we talk about seismic waves. So let's go ahead and move me here. So whenever you have an earthquake, the waves from that earthquake, the energy it releases, are picked up by these things called seismographs. You might have seen these in the movies, on TV somewhere, right? You have the little needle and the paper's running along, and as the earth shakes beneath the needle, it tracks the waves, how big they are, how frequent, what's going on with the earthquake. And there are two kinds of earthquake waves, or seismic waves, that we are going to talk about. We have body waves, which travel through the body of the earth, like this, and surface waves, which travel along the surface of the earth. Now, for the most part, we are going to focus on the body waves. Those are the ones that we have the most interest in as geologists. So we have our P waves, our primary waves, first ones to get there. Very first waves to show up on the seismogram. The needle first starts moving. These are compressional waves. They arrive first. These are going to be alternating pulses of compression and expansion, something like a slinky. More on this later. They can pass through any medium, solid or liquid, just like something like sound can go through a liquid, so can the P waves. Next are S waves. These are shear waves. These are arriving a little bit slower, S, secondary, slower waves to arrive. These are going to be what you usually think of when you think of a wave, like waves in the ocean, side to side, up and down forces. You might imagine that you take a rug and you do this with it and you have that wave that's traveling up and down as it goes forward. That is like a shear wave. Now, an important thing to note about S waves, they do not transmit through liquids, solids only for these. And we'll see why those are important in a bit. They also tend to cause more damage. These tend to be the bigger waves, as we can see on our graph over here, right? Bigger on the graph, bigger waves arrive second. So here's another way of looking at it. We have our P waves up here, and the wave pushes and pulls and pushes and pulls and pushes and pulls in the same direction that the wave is traveling, sort of like a slinky. We have our S wave here. So the wave is going up and down as it travels along like this. So just a reminder, P waves and S waves are both body waves. They travel through the body of the Earth, the interior. There are surface waves, like Love waves, Raleigh waves, but we're not going to talk about those as much. Now, I'm actually going to show you a video from somebody else that I think helps to illustrate this. Let's watch. So we have our P waves, compressional waves up here, and our S waves, transverse waves, undulating waves down here. P waves are compressional, so all the motion is in this direction, here. And for the S wave, on the other hand, we have up and down motion, even though the wave is traveling in this direction. Okay, so we have an earthquake somewhere in the world, and that earthquake is recorded on a seismograph, which is listening to it. But what exactly is the seismograph noticing about the earthquake? What is it measuring? Well, it's noticing the size of the waves, the amount of shaking. So we might see P waves coming in first, a little bit of shaking here, the needle's moving just a little bit, and then we have the arrival of the S waves. And the needle starts shaking a whole lot. And somewhere in here, right about here, we get the maximum amount of shaking of the needle. And this is going to be our maximum amplitude. That's the amount of distance between our zero and whatever the biggest peak is. It could be up here, could be down here. We're not concerned about that. What we want to know is how far away from the baseline. So in this case, we would call this our amplitude, or maximum amplitude. And it's going to be about, 21 to 3 millimeters on the paper for the seismograph. It should be 23 over here. The other thing that we're really looking at on the seismograph is the time difference between the arrival of the P waves, which come first, and the arrival of the S wave. And it looks like here would be about, 25 seconds. Next section is scary. We talk about hazards.